So we are looking at what we call stoichiometry. So for the past couple of days, you guys have been looking at limiting reactants. So when a reaction takes place, you have reactants on one side and products on the other side. So you have things that react that give you products. I asked you to build a s'more. So your reactants that you have for the s'more are the graham cracker, the chocolate, the marshmallow, and then all together they give you a synthesis reaction, which is the s'more itself. But how much do you need of everything? How far can the reaction go? So we're going to look at specifics in actual reactions. So looking over this sheet, stoichiometry is the process of determining how much product is made or how much reactant is needed during a chemical reaction. In order to make these predictions, we need the balanced chemical equation for the reaction. So here's a recipe for hamburgers. You need a bun and 2 patties and 2 cheese and 4 bacon. That's a lot of cheese. It gives you a double bacon cheeseburger. If I have 5 bacon double cheeseburgers, how many hamburger buns do I have? And then if you change things up, but then you can also do it with a chemical reaction. The math and the concepts are identical to the above example. The only difference is the recipe. So let's say we have sulfuric acid, sodium hydroxide, and it gives us sodium sulfate and water. We have a balanced reaction. We have 1 part sulfuric acid, 2 parts sodium hydroxide, 1 part sodium sulfate, and 2 parts water. So instead of saying parts, we can use the word mole. If I want to make 5 moles of sodium sulfate, how many moles of sulfuric acid do I need, and how many moles of sodium hydroxide do I need? There's other things that we can change around as well. We, in the past, looked at changing moles to grams. So here's some problems down here that ask us about grams. So there's lots of different things that we can do once we have a balanced equation and we know what the ratios are within the equation. So what I want you to do is I want you to take a few minutes and read over the instructions. So I've attached this in the classroom, so take a look at this. Stoichiometry, predicting amounts in reactions. It gives you a basic summary of how you should set up each of your problems when you're trying to determine how much product you need or how much reactant you need. So look over those 2 pages in your notes for a couple of minutes. So hit pause and go ahead and do that. All right, so I hope you have looked over the set of instructions. So what we're going to do now is we are going to work through a handful of these problems. So what's always handy is, of course, your calculator. You will want your polyatomic ion sheet. You will also want a periodic table, because these will be referenced in the event that the equation is not given to you, and that happens from time to time. At this point, you should be able to put together some basic equations. We haven't worked on them that much, but you should be able to put some together. Example 1. Lead will react with hydrochloric acid, which is HCl, to produce lead 2 chloride and hydrogen gas. How many moles of hydrochloric acid are needed to completely react with 4 moles of lead? So the first thing we need to do is write down the equation. So lead in my periodic table is Pb. It reacts with hydrochloric acid, which we are told is HCl. It produces lead 2 chloride. So lead 2. It has a +2 charge. And chlorine is Cl. If we look at our periodic table, chlorine is here. It has a -1 charge. So in order for this bond to be balanced, this is PbCl2. We need 2 negatives to balance out with the 2 positives. And hydrogen gas. Hydrogen gas is diatomic, so it's H2. Look at our equation. Is it balanced? I see 1 lead, I see 1 hydrogen, 2 hydrogen. So I'm going to put a 2 here. So now my hydrogens are balanced. I have 2 chlorines, 2 chlorines. All right, my equation is balanced. So hopefully that was okay for you. So the next thing that we're looking at is it asks us how many moles of hydrochloric acid are needed to completely react with 4 moles of lead. So my before, so I have a before, change, and after, and I'm always using my moles in my table to predict what I will have in the reaction. So I have 4 moles of lead. So before, I have 4 moles. I'm asked how many moles of hydrochloric acid are needed. So this is our question. We don't know what it is that we need. When we have our products, these are always 0. So we're assuming that all of this is going to get used up. So we subtract 4 moles. And at the end, this will all get used up and it will be 0 moles. Now what I need to look at is there's an imaginary 1 here in front of the lead. There's 2 in front of the HCl, so that means we're going to use up twice as much HCl as we are of the lead. So 2 times the 4 gives us 8 moles. This is what we're going to guess is going to get used up and leave us with 0 moles. It doesn't necessarily ask us how much of each of the product will be used. It asks us how many moles of hydrochloric acid are needed. So we need at least 8 moles because it's twice as much as the 4 that was given to us. This is what is answering the question. If you wanted to go over and look and see how much of the lead chloride would be produced and how much of the hydrogen gas would be produced, we see that there's an imaginary 1 here and an imaginary 1 here. So we have a 1-to-1 ratio, so that means we will produce 4 moles. And same here, 4 moles. This should be down here a little bit. So this gives us 4 moles of the lead chloride and 4 moles of the hydrogen gas. Example 2, how many moles of hydrogen gas will be produced if 2.5 moles of calcium hydride react according to the following equations? So we are given 2.5 moles of calcium hydride, which is this. So I'm going to put my 2.5 moles here. We are asked how many moles of the hydrogen gas, so this is what we're looking for, the hydrogen gas. We are going to assume that this is excess. We start with 0 and 0. All right, so now this is what we were given. This is what we want. So we want to know the number of moles here. We have a 1-to-2 ratio. So if I use up all of the calcium hydride, I'm going to use up 2.5. The water is twice as much, so that means we will use up 5 moles because 2.5 times 2 is going to give us 5. Calcium hydroxide is a 1-to-1 ratio with the calcium hydride, so that means we'll produce 2.5. The hydrogen gas is twice as much as the calcium hydride, so that means this will be 2.5 times 2, which gives us plus 5 moles. So in the end, this gives us 0 moles. This is probably the excess, which we don't necessarily know. And we should have 2.5 moles of the calcium hydroxide, and we should have 5 moles of the hydrogen gas, which is what we were asked to find. Example 3. How many moles of water will be produced if 0.45 moles of oxygen reacts to the following equation? We have 2 moles of this. This is a hydrocarbon. It has hydrogen and carbon in it. We have 15 moles of oxygen, 12 moles of carbon dioxide, and 6 moles of water. By looking at this reaction, you should know, based on the patterns that we've looked at, what type of reaction this is. This is a combustion reaction. Not that you're asked right now, but it's just one of those things that you should know. So we are given 0.45 moles of oxygen. So 0.45 moles of oxygen. How many moles of water? So this is what we want to know, moles of water. So step 1 is to make sure we have a balanced equation. I'm going to do a quick peek. There's 12 carbon, there's 12 hydrogen, there's 12 hydrogen, 30 oxygen. So there's 24 and 6, yep, so we're balanced. Alright, so that's our step 1. Step 2, we're filling in what we know. So we're going to assume that this is the excess reactant. We start with 0 and 0 moles. Alright, so now we need to look at the change. We have 0.45 moles of oxygen. We're going to assume that all 0.45 are being used up. This is our excess, so we're going to just leave it as excess. What we're looking at is how many moles of oxygen we will, using the 0.45 moles of oxygen, how many moles of water we will have. So notice our relationship here. We have 15 parts here. We have 6 parts here. So in order to calculate how many moles we will have, we need to take what we're going to, the water. So there's 6 parts of water and 15 parts of oxygen. This is not as simple as doubling like we did up here. This one's a little bit difficult. So we take the 6 that we're going to from the 15 that we have, multiply that by the 0.45. So in our calculator, we will take our 6 and divide it by 15, multiply that by 0.45, and that gives us 0.18 moles. So we have 0 here, we have 0.18 moles of water. We could also calculate the carbon dioxide if we wanted to. For this one, we would take the 12 and compare it to the 15 and multiply that by 0.45. So 12 divided by 15 times 0.45 gives us 0.36. So we should end up with 0.36 moles, which when we look at our comparison here, we have 12 moles of carbon dioxide and 6 moles of water, so this should be twice as much as that. This is what we were asked for. So that is our answer. Let's look at one more example. How many moles of calcium sulfate will be formed if 2.45 moles of calcium hydroxide react with an excess of sulfuric acid, which is H2SO4? Note the second product is water. So we first have to write our equation. So we have calcium hydroxide is reacting with sulfuric acid. So calcium hydroxide, so calcium is Ca, hydroxide is OH. Calcium, according to our periodic table, is a +2. Hydroxide, according to our ion sheet, is a -1. So that means I need 2 of these, plus sulfuric acid, we're given as H2SO4, and the reaction occurs and we are given calcium sulfate, so calcium is Ca, sulfate is SO4, and it's a 2 charge. So is calcium, so this is balanced right here. This is a +2, this is a -2. And the other product is water. So let's look at our equation. Is it balanced? Calciums, we have 1 sulfate, we have 4 hydrogens and 2 oxygens. So let's put a 2 here. So now we have 4 hydrogens and 2 oxygens, sulfate's balanced, so we're good. So what we are given, we have 2.45 moles of calcium hydroxide. So we have 2.45 moles of calcium hydroxide. We are told that this is in excess. We start off with 0 and 0. So our change, everything is going to be used from the calcium hydroxide, we're assuming that. And that leaves us with 0. We're going to assume that we have a 1-to-1 ratio here because it's balanced. So that means that we'll use up 2.45. It's in excess, so we're going to leave it in excess. But we know that it's a 1-to-1, so I'm just going to write that down. We are asked to find calcium sulfate. Calcium sulfate is also a 1-to-1 ratio, so that means that we should end up with 2.45 moles of calcium sulfate. So that gives us 2.45 moles. If we wanted to determine the water has twice as many moles as the calcium hydroxide, so this would be doubled. So 2.45 times 2 would give us 4.9 moles of water if we wanted to calculate that. We were just asked to find the moles of calcium sulfate, so this would be our answer.